Hello, everybody. So now we will ask you please to close your mics and still keep your cameras open. Welcome to the fifth and final session of our online lectures. Today, our lecturer will be Dr. Shani Rohatyn-Blitz. During the lecture, there will be no questions asked, but you are very welcome to write, if you have questions, to write them in our chat. After she finishes her lecture, you will be able to ask the questions directly, and we will, and she will see the questions that you have written in chat and answer all the questions you have. So I would like to present Dr. Shani. Dr. Shani is a coordinator for research and foreign relations at the Kakal GNF Forestry Division. Dr. Rohatyn-Blitz is an expert in forest-climate interactions in arid and semi-arid regions and actively leads policy and research initiatives in forestry at both national and international levels. So Shani, please, the floor is yours.
Thank you very much, and thank you all for joining us this session, the last session of our webinar series. I'm very excited to start this lecture, and I'll share my screen just in a second. So, as mentioned, I'm going to speak today about forestry and climate change challenges in forestry. We will start with a short video, and then we go deep into the research and knowledge we gain. This video is made by our chief scientist. I hope you can hear the sound.
Climate crisis is a scientific fact. CO2 concentration increased dramatically. Temperatures are rising. In Israel, the temperatures are already 2 degrees more than temperatures in the 1970s. Winters are hotter. We have less rain, but when it comes, it causes floods. The summer are drier and hotter, and we have greater risk for droughts. So what can be done? The most effective tool humanity has in order to reduce atmospheric CO2 concentration is the forest and the trees. We, KKL-GNF, responsible for the forest in Israel. We conserve the forest and even enhance it in order to sequestrate atmospheric carbon. Another tool is to use renewable energies instead of the fossil fuel energy. We recently established the KKL-GNF Climate Crisis Center. Through R&D and pilot projects, the center will lead approaches to the reduction of fossil fuel emission, what we call mitigation, and preparation for the future climate change adaptation. So what is adaptation? We have to be prepared for the future drier and hotter climate. The forest should be adapted to survive with less water. Therefore, we should fix and improve the water balance of the forest in order to adapt it for the future drier climate. In order to improve the water balance, we should more effectively use the natural water resources and increase the production of additional water resources. We at KKL-GNF decided to fight the climate crisis with all the resources we have. If we cope with the water challenge and conserve the forest here in Israel and worldwide, we have a chance to hold on and even win.
Okay. So after this glimpse of climate change and forest introduction, we go straight to describe the challenges and the solutions that we in the Forestry division provide for the forest managers. So, as mentioned in the movie, in the short movie you just saw, and as you're probably all familiar with, carbon dioxide increase over the last decades. And you can see here the sharp increase of CO2 measured in the Mauna Loa. I'm sure all of you are familiar with this figure. You can also see the increase in temperature, which is already reaching increase of above 1.5 temperature Celsius, and we are heading to the 2 degrees and even more. What does it mean? It actually means that we have a lot of loss of habitats, endangered species. Here in this figure, you can see a snapshot from 2019 for the different species and how embedded they are. So we have loss of 40% from the amphibian species, 33% from the coral reef species, loss of 25% for mammals, and more than 33% of marine mammal species. So a lot of species are in danger, and we need to do something about it. What's going on in Israel? Israel is a dry country. We are just on the edge of the desert. So every change that is going on with climate is even more extreme here. We already observed, this is data from our Israel Meteorological Service. We already observed a significant increase in mean temperature, in some places above 1.5, but on the average of Israel, increasing 1.5 Celsius. And the projections, which you can see here, are that on the business as usual scenarios, Israel will have above 4 degrees increase. This means a large change in an area where already the temperature are quite high. Regarding rainfall, the trends are less significant. You can see here on the right the map of Israel, the difference in millimeter per decade. If you look of 2022 and 1970, and you can see in the upper north we have a more larger increase in decrease in millimeters. In some areas we have increase in millimeters. So the change in millimeters in rainfall amount is not equal all over Israel, is diverse. But on average, you can see a decline in 25 millimeters per decade. It's not significant, but yet it is something that has been observed. And you can imagine that when you are already on the edge of arid zones, and this is quite a significant decline. And why our forests are so important for combating this climate change? We know that forests are a large carbon sink, so forests absorb above 15 gigaton CO2 per year, which is a large amount of the CO2 emissions. Is it by different forest ecosystems? You can see here that the boreal forests are a large part of this budget. Wetlands are also known to have been large participant of this carbon budget and carbon sequestration. They are also regulating the climate. So forests influence rainfall on a large scale. If you talk about tropical forest and cloud formations that they create, the Sahara, the Sahel forest that can create more cloud formation, increasing rainfall, and therefore changing the water cycle. They're also important for soil and water protection. The roots of the forest are preventing erosion. This is something that we are using in a project of combating desertification. They reduce the flooding, and they also provide cleaning water. Of course, they are habitat for large species, diverse species. 80% of the terrestrial species worldwide are held by the habitat of the forest. And they support the local community. So forest can provide food, medicine, livelihood. And in Israel, of course, in such a small country where you don't have a lot of shade, then they can provide a lot of recreational area. What are the main challenges that we deal with when we talk about climate change? So climate change decrease the available water. We have lack of water, and therefore we see, this is an image you can see from a semi-arid forest in south of Israel, Yatir forest, of a large drought effect that we had with a lot of trees died over the first decade of this century, of the current century. We have reduce of the natural regeneration. We have, of course, also the effect of forest fires when the biomass is getting drier and the population is getting larger. So ignition can be more rapidly, and we have large fires occurring over the last years. I will talk about this more. Invasive plants and species and also insects are maybe a side effect of climate change, but definitely are increasing with the increasing temperature. So opportunities are being taken by species that are not belonging to the ecosystem and can have devastating effect on the ecosystem. And we also have extreme weather events that are getting more and more frequent, such as storms and snow. So in order to deal with all these challenges that I'm going to go over in this lecture, I first want to talk about the importance of research, because we know that policy and management have to be based on science and based on data. This is we in KKL-JNF, we understand that we need to invest in long-term and short-term research in order to have a more adaptive and resilient ecosystem for the climate change. So we have 5 long-term ecological research stations. You can see here on the map. This is, sorry for the map for being in Hebrew, but what you see here all around Israel is station of the LTER, long-term ecological research stations, which are part of the Israel network, which is part of the European network. I'm not know, maybe some of you are familiar with this term, LTER, and we are taking part of it. So 5 of the stations that are marked here in green are managed by KKL, and we invest in them. We also have long-term, sorry, I'm in the middle. Open office. We also have 2 long-term monitoring systems, monitoring our old growth Aleppo pine forest and monitoring rainfall and runoff and runoff. Sorry, I have someone that is waiting here. I will just give him whatever he needs and we'll continue. Okay, I'm with you. We also have dozens of short-term, 2 to 3 year studies. All this knowledge that is gained over the years is helping us in order to provide scientific-based knowledge for managing our forests. So a little bit more on that. Here is an example, a case study for Yatir Flax Tower. It's a forest, Yatir Forest. I think we mentioned it in some of our previous lectures. It's a flax tower, which is part of the flax net, an ecovariance measurement, which measures CO2 and H2O fluxes interactions between the atmosphere and the ecosystem. It is in the forest, in Yatir Forest, which is around 280 millimeters of rainfall. You can see here the dry area where it was planted around 80 years ago, 60 to 80 years ago. And with this station, we can have pioneer studies to study the interaction of such a unique forest, of Aleppo pine forest with the atmosphere, and also understand how is this forest is so resilient to drought, because you can see that even though it's growing in such a challenging environment, it can still survive many years and grow these beautiful trees, providing all the ecosystem services that I mentioned before. Another example is our forest density manipulation studies. We have two manipulation studies, one in the Yatir forest, which I just mentioned before, in this Aleppo pine forest, and the other one is in a more Mediterranean forest, which you can see here on the right. In each site, we have manipulations that we did for density. So we did we cut the trees, we removed biomass in order to have different density of the forest. And for over 20 years, we measure every year the same measures in order to see how is the forest thriving, how does it produce all the services that I discussed before, how does it grows. We measure biomass, we measure height of the trees, the canopy cover, we measure LEI, we measure all these measures in the same plots for many, many years. And by that, we can understand what is the most resilient and most optimal density for our forest, for this Aleppo pine forest, to exist. It could be from 100 trees per hectare to 300 trees per hectare. It's not a lot, but it is important to understand that we don't have trees for commercial reasons. So they need to provide ecosystem services, but they are not for biomass. So just if I can conclude this very shortly, then we have the semi-arid forests, they require more lower tree density in order to provide more water per each tree. And the Mediterranean forest, they can have more higher density in order and still maintain resilience and natural regeneration. Another and last case study from our science researchers is the runoff harvesting stations. So we have two LTER stations that provide, again, above 20 years of data that we measure. How does this, what you see here in the image, the Shani forest, which is a water harvesting forest, how does these trees grows in this water harvesting system? So we first had the Sayeret Shaked Park station. You can see the small gauge that collect the water, and by collecting this water, we managed to create knowledge in order to understand where exactly do we provide a contour line for the trees. What is the distance between the contour lines that we need to make? How do we build the terrace? All this knowledge is from this research. And then we planted the forest And we have another research station in this planted forest that is based on the knowledge that was gained from the other research. So all, as you see, is science-based policy. So after showing you all that, how do we invest in science and how science is important, I would now want to go through the challenges that I spoke in the beginning of the lecture that are having in the forest under climate change. So the first challenge that I mentioned, the lack of water, which is creating the death of the trees and decrease the natural regeneration. In general, what we see is that prolonged drought and heat waves can create more mortality events. And we have also, even more important is the shift of the rainfall distribution. So we have longer dry season, and therefore the trees need to be resilient to a longer period where they don't have rainfall at all. Here in the image, you can see a model done by Israel Meteorological Service, and we can see that all around Israel, from south to north, we are going to have a larger and larger decrease in precipitation. So this is the projected change in annual average rainfall in millimeters, which can reach up to a reduction of 100 of millimeters per year, which is a lot. What do we do with that? So we understand there is a lack of water, and we understand the trees will need to be more resilient to drought. The first management tools that we have, or strategies that we have, is thinning. Thinning operation is the best way in order to provide more water and more nutrients and resources for the trees. So 6 years ago, there was published a guideline for thinning of conifer forest, which is the main forest in Israel. And these guidelines were published based on the sites that I showed you before. They provide like actual numbers of how do you decide when to thin, how much do you want to thin, what percentage of cover do you want to gain in order to gain which different target of the forest you have. So this was a very large step in KKL, in the forest agency, because now the managers, they know, they have the exact prescription for how to thin the forest, and it really depends on where the forest exists and what is the climate in the specific forest and what is the target or the goals that you want to gain by this forest. Another important strategies that we need to use is, of course, using more resilient, drought-tolerant native species. So here in this example, you can see field experiments that we did allocating outstanding ecotypes of Acacia radiana. And then we could see, we could monitor which of the ecotype thrive the best, and we can choose this ecotype and propagate it in our nurseries that you heard about 2 lectures ago, and then we can improve our forest and trees in the forest to be more drought tolerant. Another strategy above that is, of course, using water harvesting system. In our second lecture, I think Gil spoke about it. We have different shikts, we call it, contour lines that we kind of terrace that we are using. We also have the mini catchment, what you can see here on this figure that is already full with water. So we are using both these techniques in order to provide larger amount of water to these trees where they grow in a very drought and dry area. We also want to support more natural regeneration. And we have two ways in order to do that. Of course, we have grazing, and grazing is eating the natural regeneration, but it's actually providing more water to the existing large trees. So it is important in order to improve the water dynamics. And what we do in order to keep with the grazing, but actually allow for more natural regeneration to occur, is we are using this, and I'm not sure if in this figure you can see it clearly, but we have kind of a small individual protection of the natural regeneration. In this example is oak natural regeneration, and then we can keep the tree to grow for its first few years, and when it gets to a larger size, we can remove this individual protection. So this is a combination between protection of the trees and grazing for improving the water dynamics that we created. Okay, so after I spoke about the lack of water, our next challenge, a large challenge that I'm sure all of you are familiar with, is forest fires. Forest fires are increasing in frequency and in intensity. The fire season length is increasing. We see now more and more early fires that are early in the season that are occurring. And I will give our specific example of the last fires that we just had in Israel in a few slides. We also see that we have higher fuel load because the vegetation is drier, a drier winter, and even higher intensity of drought events create drier vegetation. When the vegetation biomass is drier, the fuel is more easy to be lightened. And of course, we have the human cause. In Israel, all fires are caused by human, not always intentionally, but it could be just last week we had a fire that started from a broken rope of electricity, a broken wire of electricity. So it's not someone that did it, but it was just, I don't know, neglected, or the year came by and this is how the fire started. So it's all, we don't have lightning fires, no summer storms. So it's all made by human. And when we have more human, when the population increases, we have more fires. Here in the picture, in the map in the middle, you can see a work done by the National Plan for monitoring the state of the nature, which we are also part of. And you can see they did a map of the what you see in the colors in here, in 1 to 5 to 7. This is number of fires in the last decade. So some places in the last decade had more than between 5 to 7 fires events, which is a lot. And you can think about this vegetation every time, every year, they have another fire and another fire, and then we have a loss of the seed bank and a loss of the habitat and a loss of biodiversity. And this is not a good thing, of course. So what do we do with that? In KKL, we implement policy of fire prevention by having forest management for fire prevention master plans. The general idea is that we use different zones around villages and inside the forest with different fire prevention management. So you can see here in this illustration on the right. So you have the village, you have the buffer zone around the community, which is the area where you reduce biomass the most. And then we have the yellow zones, which is areas that are area where you want to reduce fire threat, but it's not on the villagers or not on the community, but it's actually usually around the roads. This is very important because when you have a fire, you want to have the ability to get firefighters inside, to get a truck inside the forest to be able to get the fire off. And we also have zones. This is the green zones where you want to mitigate for the risk of mega fires. So this is just an illustration for how do we decide where do we want to have which type of management for fire prevention. What we do, we have a master plan for our forest, and in this master plan, we have a specific plan for fire prevention. So this is an example from Ben Shemen forest. It's a forest between Tel Aviv and Jerusalem. And you can see here in this plan that you have different areas that are marked in order to do fire prevention management work. So the green area is, again, it's different colors between, but the green area is along the road. This is a fuel break in order to provide a valuable road for firefighters to insert the forest. You have also the area in orange, which are areas that we know that we want to protect, around communities. Here, for example, you see a large green area. This is an area that we know that people are coming intensively for campsite and for barbecue. This is why we decided that this area has to be managed for fire prevention. So we do this plan, and then this is a long-term plan, but the manager, the forester, knows how to take this and make it to an actual working plan in its annual work. Here you can see an example for how a fuel break looks just before the management actions and after, removing the biomass, keeping only trees, mostly broadleaf trees in the 5 meters distance from the road. But what more important is the distance between the trees. Okay, so we have also how many trees do we want to keep on each kind of each zone, but also what important is the distance between the trees. And for a case study, just from, this is like, maybe one of the first to see this data. So we had a fire in the end of April, 2 weeks ago, I think, 3 weeks ago, very large fire in the scale of Israel. So we had 2 fires. This is the second fire, but altogether they had 1,850 hectares being affected. What happened here is we had a very extreme high wind and dry days, but we also had a very dry winter. So as I said, the vegetation is very dry. We are getting into the fire season, which we usually used to have fires like this in the end of the season when the vegetation is very dry. But here we see, because we had a very dry season, winter season, then also large-scale fire, in our scale is the large scale, is occurring also in the beginning of the season. And what, it's very initial consequences, because they are still working just now on security and understanding the behavior of the fire and what really happened. But we already know that fuel management really helped in this case, because it could have been much larger. I don't know if you can see it in this map, but the area here, when you see the road 1, is the road that's going from Tel Aviv to Jerusalem. All this area is large area of forest that was being saved because of a clear fuel break that managed to stop the fire over here. Devastating, a lot of work to do now, a lot of work that has been done and damaged, but this is the reality. Going deep to more challenges. So we spoke about lack of water, we spoke about fire. We also have extreme events that are actually not related to drought. They are on the opposite side of drought events. We have storms and snow events that can occur more rapidly. Here is an example, actually 10 years ago already, from a widespread collapse of Aleppo pine trees that was collapsed after an intense snowstorm. So of course, Aleppo pine is not a snow-resilient forest, and we know that we evidence this not only in 2014. We had a large storm event in the south in 2021, and we had before that in the north in 2018. So more and more events of large collapse of trees due to snow or even just storm, so large wind storms. Again, what can we do with that? We use thinning. We want to have, instead of having a very thin trees, very like matches, we call it, and very dense forest, we understand we have to have larger trees with larger size of the roots area. This is in order to reduce the heaviness of the top of the trees. So if a storm is coming, if a snowstorm is coming, the tree is more rooted to the ground and it's less affected by the extreme event. We also need to understand how to change the structure of the tree. So we do use in some places, when you know recreation areas and people are more rapidly coming to this forest, so we know we need to do pruning to remove large branches that can fall over people. And this is something that we are doing frequent. And of course, choosing also what are the best trees for each habitat. So this is maybe the most basic strategies that we have to use. We have now an experiment in the north of Israel using different pine species that can be more tolerant to snow and storms. But we are more and more going into using native trees, using more adaptive to this kind of weather species. Finally, regarding the challenges, we have these two challenges that are, let's say, more side effect of climate change. We have invasive plant species and invasive insects. Here you can see different invasive species that are opportunistic. They see that the habitat is changing. There is an opportunity. The trees or the shrubs can die, and then the invasive plant are overtaking the habitat, overtaking the ecosystem. We had Acacia saligna, which is already spread all over Israel. It's brought to Israel by the British, and in order to actually provide a good ecosystem service, they wanted to stop the dunes from coming inside the country. But they didn't know that acacia will spread, and I think it's a problem not only in Israel, but globally. We have also the what we call camphorweed. It's also going over our dunes. And when such species are coming, then there is no space for any other natural herbs, natural shrubs, natural trees to regrow. This is why it is very important for us to deal with it. And of course, we also have the knowledge that any disturbance that is coming, it's an opportunity for these species to come over. What do we do with it? So we have quite a pioneer study that is prioritizing for us where to treat, because you can't treat invasive species all around in the same amount of investment. You have to decide where to go, how to treat, which area, and this is why we started to use a more advanced tool. So here you can see already results from a study just from this year, from the last year, that done by institute in Israel, Machon Shamir, Shamir Institute. And this researcher, they're using a motorbike with cameras, and they map the area of the forest. Okay, you can see here the blue line is the trail where the motorbike took place. And then it's collecting data. And it's collecting data by this motorbike, but it's also collecting data from a lot of data that I showed you that we monitor and collect by our different monitor systems. And this model that is using 6 different factors in order to provide us with this priority map. Okay, understanding where do we need to treat and how much do we need to treat the invasive plant. So just in a glance, we have here the distance from external seed source. This is one consideration we need to take. Topography, If the topography is very sharp, then we know we have the seeds can go rapidly down the hill. Proximity to trails. Of course, trails, bikes. So we have a lot of biking around the forest. Even just people or cars, 4-wheel cars, they can go and take together with them seeds and spread it all around. This is why it is important to understand how close you are to a trail. Time since the last fire, because as I said, a disturbance can increase the occur of invasive plant and the opportunity for them to thrive. Proximity of to wetland. This is important depending on the species, of course, and ecological hotspot, because if it is a very high ecological hotspot, I would like to treat it no matter what. I would like to save the important species that are existing in this hotspot. So taking into consideration all these factors, they provide for us this map you can see here on the right, where the red area is the area with the highest priority, and the green area is the lowest priority. So this is a very small example because, again, this research is just coming out of just now, but this example is showing you how, in theory, we can use such a model. Last is the invasive insects. So we have pests and pathogens that actually thriving under the stress of the trees due to climate change. So if the tree is under stress, if it is because it had a fire or it's drying because of a drought event, then the insects are now the next stage to come, and they can damage the forest in an even larger effect. So here you can see this image where we had the bark beetle attack after a hot and dry autumn. So this is just one example. But our understanding is what we need to do is actually to manage the abiotic stress. If we manage right for the abiotic stress, we have less effect of the biotic stress, the pathogens and the pests. So again, we go back to the first challenge I spoke about, the lack of water. This is what we first need to do here. But of course, sometimes it doesn't help, and the trees are still in stress, and we have to do something like sanitation after a disturbance. So sometimes we even have to come and use pesticides if this is needed. We also have research that is providing genetic improvement of the trees, that to be more tolerant to specific pathogens for specific pests. And we try now to improve also our monitoring system, because if we manage to monitor and to understand when a small event is starting, like when there is a few trees already that been ignited by this pest, then we can treat it quickly and we know it won't spread. But if we don't monitor properly, and it's already on large scales, and it's very difficult to deal with. So after going over all these different challenges, I want a little bit to look ahead. What can we do in the future? Because a lot of what has been done in the past is based on great knowledge that been taken by the forest manager, by researchers, and today we have more high-tech technologies that we can use in order to provide more efficient management of the area. So is this what we want? I'm not sure. Do we want to stay more in the past? Do we want to go more in the future? I think we want a combination. But some case studies that I want to share with you here. We now have more and more tools in order to use what we call smart thinning. So in order to do the operations of thinning in the forest, the manager, they first need to come and to monitor what is existing in the forest, what we need to treat, how much biomass there is, and how much biomass do we want to remove. So we use remote sensing on different levels. Here in this image, illustration, you can see we use remote sensing on large scale, we use aircraft, and more available are now the drones that are becoming more in use. And also what we call the, not remote sensing, but the close sensing. I don't remember now the name, but cameras all around in the forest. And here in this example, it's a video done by Enzo. It's one of the companies that we work with. They wanted, or we wanted to have, be able to monitor the biomass before and after we are doing an operation of a fuel break. So like I showed you in one of the slides before, it's a similar operation. And here in the video, you can see the drone. It's been taken by a drone and LiDAR, if you're familiar with this technology. So you can see the forest taken by a drone. You can see the trees. This is all image by LiDAR. And you can see the removal. Okay, so this is before and after the removal of the biomass. In this way, the forester can plan in a better way how to bring the workers into the forest, which trees do they want to take, how will the forest would look after the treatment. And this is a very efficient tool, still in work. It's not something that is used all around, but we are heading there. Yeah, so this is just an example. Another example is our precision irrigation, which is actually taken from, I believe some of you are familiar with it. It's taken from agriculture, but it's much more complicated when you manage, we're trying to do precision irrigation in a diverse ecosystem like our natural forest. Or even if it is a planted forest, it's already has a natural regeneration and it's very diverse and it's not so easy to monitor. So here in the left side, you can see a map of the humidity, soil humidity model. And you can see that in these plots, each plot is a different plot for a plantation. There is trees already in this area. And they monitor the humidity, and you can see the different habitat that each tree is gaining. So even if I planted the same tree all over this area, they have a very diverse and different habitat. So they will thrive in a very different way, and they need to be irrigated in a different way. So first in this study, we understand we have to have more knowledge. We have to understand to describe the habitat of each plantation in a better way. And now we have this, just these days, we did a kind of a challenge competition between companies in order to provide for us for tools, for technological tools that will monitor the precise water content of the trees inside our plantation and be able to control the water that the trees will gain the exact amount that they need to gain. So this is again something in studying, in research that is coming to the future. Last, I want to show you another project that we are working on. It's less maybe about the adaptation that mostly I spoke in this lecture, but also about mitigation. We need to understand, we want to understand and to know how is our forest, how our forests are providing carbon sequestration for the ecosystem. So we started the work with Marvin, a company that we worked with, in order to monitor the different vegetation type with the actual above ground biomass over the years. And again, here it's been used by LiDAR, but this time it's a LiDAR on the, sorry, I forgot the name. For the satellite. So there is satellites with LiDARs that can provide more accurate numbers of the biomass. And this is an example from Yatir forest, the forest that I showed you in the beginning of the lecture. You can see how this forest here is in such a dry desert area. And we have now the numbers of how many ton CO2 this forest is able to sequester per year. And we are interested in doing this. We still need to work on the data, so this is just still in process, but we are hoping to have such maps for all of our forests. And with that, I think yeah, I finished. So thank you for listening, and you're welcome to ask questions. Yeah, I don't see the chat, just a second. Do we have any questions? Maybe you want to open some of your cameras? Everything was too clear, I understand, this time. Very clear. Nice. Okay. Yeah, thank you for all the nice words. If we don't have questions, which is very unusual for you guys, I think we can maybe say a few words for finalizing this webinar. Guys from Ashav, do you want to say a few words? Do you have questions? Sometimes Evelyn asks questions.
Thank you very much for your presentation. And then I think we learned a lot. I'm Cecily Mignar from the Philippines. I'm the Provincial Environment and Natural Resources Officer. And I learned about your fire suppression technology, about your fire suppression technologies in terms of mapping. And we can learn about that, how to, more on your strategies. I think we're very interested with that.
Very nice, thank you.
Yeah.
I see there is some question here. What methods or devices are used to measure soil moisture levels? That's a great question. It's a very difficult measure to do. But we actually, in the last year, we kind of think we found good solutions, because you can imagine that measuring soil moisture in such a dry environment is very difficult. We do have specific methods that we are using, and I can share with Homero, if you are interested, and you can write me your email. I can send you details about the specific sensors, but we have very nice methods that now we are using, and it's actually part of what I mentioned, the LTR network that we have for long-term ecological research, that it's struggling not only in Israel, but also in Europe, to have a continuous humidity, soil moisture humidity monitoring. So I think we have a nice solution, and we'll be happy to, I don't have exactly the name of the sensor, but I will be happy to share with you. We can get with this sensor actually quite deep inside the soil, and you have a remote, on the trees, you have a collector for the data remotely, so you can control it from remote, and it's very nice. And we'd be happy to share. This is something maybe for Mashav. I don't know if you follow the questions in the chat. They're asking about certification from the webinars course. So I don't know if you can answer about it. I don't have the answer regarding it. What sensors do you use in determining the CO2 level? Okay, so, and what sensor do you use for droughtness? Sorry, I don't see it. I have something on it. For droughtness of the forest. LiDAR was quite expensive for some, but does your group use ground sensors? So yes, we do measure biomass not only by LiDAR. We have, we also collect dry biomass, so you can come and collect dry biomass and use allometric equation that was provided for our specific forest, and then you can upscale the biomass from what you measure, the dry biomass that you measure. With the upscaling, you can get to the above ground biomass, and from that you can get carbon, which is 50% of the biomass. So this is one way. I showed you the flux tower in Yatir forest. So this kind of method is an eddy covariance method. It is measuring the fluctuations of the CO2 concentration and the changes in the wind. And by that, it is measuring the turbulence, how it, and it can see the change of CO2 that is coming up from the forest and down from the forest. And it's a very precise measure. And you can measure by that the what you call GPP, if you are familiar with, or NEE, the net ecosystem exchange between CO2, between the biomass and the atmosphere. So this is another method, not so cheap, of course. Yeah, I think this is, and you have different methods also, others, but this is the main. So you have allometric equation using collection of the data from the field, and you have this eddy covariance measurements and remote sensing.
Thank you.
You have Fabrice with
Thank
your
you,
hands up.
ma'am. Thank you very much. I'm already cleared on what you answered. So yeah, thank you very much, ma'am.
You're welcome. Fabrice,
Yes.
our excellent student, always have great questions.
Okay. Thank you, Shani. Thank you very much for this good presentation that you've been giving us. It was very good and very informative about what we have been spending the whole about 3 weeks, right? If I'm right. So I have to come up with 3 questions.
Try to speak a little bit louder because it's difficult to hear.
Okay, are you getting me now, right?
Yeah.
Getting me? Okay, good. I was saying that thank you for taking us through the whole journey that we have been spending these 3 weeks. It was very good and very informative.
Fabrice, I'm sorry, but I can't hear. If someone hear him and he can write it, or you can write it on the chat, because for me it's difficult to hear and I just don't wanna.
You're getting me now, right?
Yeah, better.
Okay, good. I was saying that thank you for taking us through the whole journey of I've been spending 3 weeks a week. It was very good and very informative, and I was very excited to be part of this conversation. Basically, as I was said, I coming from Rwanda, and we are also working through the different departments in agriculture. So I have 2 to 3 questions. Like one, I want to ask, will we have the access to the PPTs that were being used through the presentations? The second goes with that one who asked about the certificate. The certificate, maybe they will be getting, they will be bringing it an answer of that. Lastly, I want to ask if it's possible that all the participants who've been participating through this program, that will be getting an additional opportunity for witnessing, seeing what we're being told at because we as scientists, we believe that seeing is a believing. So we want to see, we want to get, we want to witness what we have been seeing, what we have been understood here, like physically. If
You're
it's possible,
interested in visiting here?
Yes, sure.
Yeah, I think this is all questions that we need to discuss together with Mashav, because this is a cooperation with them. And regarding the presentations, I've been asked each lecture, and I didn't find a way together with Evelyn how to share the presentations themselves, but I will try to do that. Okay, we will work on it now after we finish the Syria, and maybe we can have actually on our website, on KK website, and then we can share the link with you guys. I will try to do that. There is also the recording of the webinars, which I think Evelyn shared with you every time, so we can send it again. I think we have all your emails, so don't worry about that. And your last question about the certification, again, I'm not sure about it. We have Ora here. Maybe can you answer this? Or Ora, do you know if they gain a certification in the end of the webinar?
We think about this, okay?
Okay. Seems that there is an interest. And of course, about our aim, part of the aim is to keep on contact with you guys. So I will think together with Evelyn, what can we do if maybe we can organize another webinar series, or maybe a more dynamic kind of class that you can ask more questions. And we will be happy to hear if you have ideas for what are you interested. I know we had like it was very broad seminar. I think we had a lot of different topics that we touched, and I'm sure some of you were interested in one thing and some of the other. So maybe you can write us what are you interested in. I will try to follow up with this. And I'm sorry for Evelyn that she couldn't join us. I didn't say it in the beginning, but she doesn't feel well and she couldn't join us today. There is one more professional question. I see from does your water harvesting comes from rainwater? Yes, we collect the water from the runoff. This is the idea. So it's, of course, only during the rainfall season, but it is providing much larger available water for the trees during the season. And we do collect data about it. I mentioned it in the beginning. We have a monitoring system to understand how much water each of these limans or the terrace, the contour lines are gaining, and providing better management tools for our land managers. And so we don't, it's not that we collect it and then we provide it for the forest. It's actually, I think, I don't know if you saw it, but it is kind of terrace that are collecting it on the exact space where the trees are planted. It's not, and when the contour is full, then the water will go to the next contour line. So this is how it works. It goes down the hill and using the runoff. We have another question about what challenges have been reported when using nurse plant in restoration projects. Yeah, so I think we talked about it 2 lectures ago, but we understand that in order to succeed with planting, we have to have good plants. So we have to have a good nursery treatment. It's a whole, it's a whole big area of knowledge, and Chagai spoke about it a lot. But I don't know exactly like how to give you a specific prescription here, because it's a lot of information. But in general, we want to provide good rooting system. I think this is maybe the basic. And then we need to know in what size is the best size of the tree in order to plant it so that it will thrive. And we need to understand how much water it gains. Yeah, there is a lot of answers to this question. And I think that is it. Yeah, I can share my contact. I would like that. No problem. Yeah, we have here actually Steve from Turkana, right? Where he's, maybe you can open your camera. I think we mentioned this project. We have a project in Turkana that we are working with the community over there and teaching how to use this water harvesting systems and grazing management. Here, Steve is here. Do you want to say a few words? I don't want to tackle you. Yeah, but this system is working. If you do it properly, it is working. I think that is it with our professional questions. I want to do a short summarize of our, just a second. Here it is. I try to summarize it in numbers. So we conclude the international webinar series on forestry in arid and semi-arid regions, the Israel experience. We did this by cooperation with Mashav, KKL JNF. It was a pleasure for me to see people from all over the world. We had over 100 professionals all together, less today, from different countries. And just here I wrote whatever I managed to get in the seminars themselves. So Kurdistan, Georgia, Nepal, Brazil, India, Uganda, Guatemala, Kenya, Spain, Ghana, Mexico, Indonesia, Cameroon, Ethiopia, Mongolia, Turkmenistan, Ecuador, Gabon, Philippines, Rwanda, El Salvador, and more, and of course, Israel. So that's a lot of countries, and it's very unusual for me to meet people from so many countries in one place, even if it's a camera. I want to remind you that all our sessions are recorded and we will share with you. And we had 5 sessions on different topics in forestry, from introduction to forest management, to dryland forestry, propagation and cultivation, advanced monitoring systems that you had just last week. And today we spoke about forestry and climate change challenges. Here is just a picture of you guys in the first session. And I want to thank all of you, the participants, the speakers, and the organizers. For me, it was pleasant. I think we have Mashav also who want to say a few words.
Yeah, but before me, there is Zavit, and she will talk before me because she's my, she's in the management of my
Stop sharing just a second so
Zavit?
we can see you.
I'm here.
Okay.
Hi, everybody. Greetings from Jerusalem. Very glad to take part in this last part of this series. Even though it was very professional with the things that all of you are dealing with, I managed to get the gist of the importance. I think that this session, this series of 5 lectures is extremely important. I'm very grateful to cooperate with the with the KKL and JNF, of course, through our long hand of Mashav Shveim. We have, of course, Giora with us today. I think this series of lectures is a wonderful example of what Mashav is all about. We like to bring professionals and experts from all over the world to the same place, whether it's physically in the same place, whether it's in your different countries, whether it's in Israel or whether it's online, to be able to talk about important issues that are relevant to all of us in many countries. So this is the core of what Mashav is all about. And it's great to see this exchange of ideas and this wonderful questions. And it's also great to understand that you want to continue this dialogue and continue this joint discussions. So everything is all of this is very heartwarming, and I'm happy that you had this opportunity to come together and to talk about this forestry in arid and semi-arid areas of the world. And I hope that indeed, maybe with the help of Mashav, we'll be able to continue on. So really, my heartwarming greetings to all of you, and wherever you are. from Mongolia to Nepal to Guatemala. And much success to all of you. And I hope this sessions brought you good ideas to bring back to your own day-to-day activities. Thank you very much from Jerusalem.
Okay, hello, I'm Giora Teffer, the director of MATC. I'm really happy, and I want to thank you for joining these courses, these Zoom courses. And I know that all the kind of subjects, the forestry and climate, it's not only belong to one country, it belongs to all the countries in the world, because we have to take care of it. You know, Cacao was formed in 1901, I think, yeah. It's been also already like 1,030 years she's working, and she's Israel, the first time, was without trees. And all the trees, most of the trees are in Israel, all the forests were made by Cacao. And they are still living, yeah, with all the thing that, the bad thing that happened with climate and things like this. But, you know, you are from more than 25 countries and all kinds of places in the world, and you have other kind of climate. And I'm happy that we can talk and pass you our knowledge. I mean, Kakal, we are just connected here. But I hope that you enjoyed the courses, and you shall keep on writing to us, and we shall be in touch from now to ever. And again, I want to thank you for joining this courses, and I wish you all a good day and a good climate. So, see you now.
Thank you.